Hello, Algebra 2. Hope you guys are doing well today. What we're going to do today is take a look at a little bit of adding, subtracting, and multiplying polynomials. Now, this is something that you have experience with at different steps. And what we're just trying to do right now is formalize this. You've done this. You've even probably taken some summatives with it, but not quite at this level. We're going to make it to the Algebra 2 level. Let's go ahead and get started here. We've got a polynomial. Fill in the blanks. I like fill in the blanks. A polynomial is an expression with one or more terms. Poly means many and nomial means terms. So many terms. Now we've got exact names for polynomials with, if you just got one term, we call that a monomial. Monomial. We've got two terms as a binomial. And three terms, we call that a trinomial. One, mono, bi, two, tri, three. That's where these three things are coming in. Once we start to get above three, like to 4 to 5, 6, 7, 8, 9, 10 terms, we just call them polynomials. It's just not worth it having all the different words for those things. You commonly will have 1, 2, and 3 term polynomials, so it's kind of nice to have words for those, but not necessarily for anything above that. What we're going to do, though, is we're going to look at some of the characteristics. If that term has a variable, we can describe the value multiplying it. We call this a coefficient. Yeah, it's going back to some good words here, definitions. Coefficient. If the term does not contain a variable, just a number, we call those constants. We call those constants. Sorry, constants. Now, again, things that we've done a bunch of times before. If you have terms with the same variables and the same exponents, we can combine those things. We call those like terms. We like to combine like terms, and that's exactly what we're going to be doing today. Combining like terms. Now, we're going to get a little more specialized into things or specific with things. We're going to put polynomial expressions, we're going to arrange them in a way which we call standard form. Standard form. We've done lots of standard forms before. For quadratics. We didn't talk so much about it for linear functions, but there is one for that too. What we're going to do is we're going to take the terms and we're going to place them in descending order according to the exponents. So descending order, according to the exponents. From the highest, from the most exponent, the largest exponent to the smallest. When a polynomial is in standard form, the coefficient of that first term, the very first term, that's kind of a unique one. We're going to use this as we go forward too. So you need to understand this concept. This one is going to be called the leading coefficient. The leading coefficient. That's going to be really important when we go to graph things or when we take and do some factoring. So it's important that we know it. We're not going to use it necessarily right now, but we need to know it exists and what it is. Can we identify it? So with that said, the first little bit here is just making some identification processes. Doing some identification processes. The first one, determine whether each polynomial is monomial, binomial, or trinomial. Does it have 1, 2, or 3 terms? Remember, terms are things that are added together or not subtracted, things that are added together. So like 4x cubed minus 8x, you could also think of that as 4x cubed plus negative 8x. So our terms would be 4x cubed and negative 8x. There are two terms making this one a binomial. You'll notice in B, there's only one term because there's nothing added together. It's just negative 5xy to the fourth. This is what we call a monomial or monomial. Monomina. Our third one is x squared minus 2x plus 1. It kind of, you can feel the rhythm a little bit, right? That sounded like three distinct beats. We've got 3 terms making this a trinomial. All right, for the next one, for number 2, it says determine whether each of the following pairs are like terms. In other words, could you add or subtract them? And I'm going to do A and B, then I want you to do C and D. A says I've got 6x squared and x squared, or 1x squared. Could I add or subtract those? Could I combine those? Absolutely, I could. They have the same variable and the same exponent with that variable. Yes, I absolutely could. For part B, I've got 9x and negative 3y. I cannot add or subtract those. I cannot combine those together because they have different variables. Doesn't even matter with the exponents. They've just got different variables. This is a no. What I need you to do is check C and D and look at D. We're going to talk about that in just a second. So I'm going to hit pause, give you an opportunity to try that. As we come back, you'll notice that letter C is no, because yes, they are the same variable. They're both x, but they're not the same exponents. In fact, 8x is like 8x to the first, and you have 2x cubed. Same variable, different exponents, cannot combine those. D, on the other hand, yes, they are. And here's the reason why. Think about it like this. If I do 2 times 3 times 4, that's like the same as 2 times 4 times 3, or 3 times 4 times 2. The order of multiplication doesn't necessarily matter. We could rearrange this so that negative 3yx, we could also call that negative 3 times x times y. So yes, they have the same variables, and those variables have the same exponents. So D, yes, those are like terms. So keep an eye out for that. So they're going to try to trick you sometimes, they being the math people, okay? Number 3, for each of the following expressions, identify the coefficients and the constants. Once again, I'm going to do A and B, and I'd like you to try out C and D. The coefficients, again, a coefficient is a number multiplying a variable. We only have one variable, that is x in here, so our coefficient is a number multiplying that, which is 7. A constant is literally just a number, and the number that just exists here is 1. Coefficient and our constant. B is negative 4x squared y. Well, our term is negative 4x squared y. Our coefficient is the value that's multiplying. We have negative 4. And our constants, we don't have one. We could think of it as 0. We can think of it as 0 or doesn't exist, right? Because you could say plus 0, but why would you, right? In this case, again, 0 or does not exist. However you want to think about that. Because again, this is like plus 0. If you want to think about it like that. So your job is to look at C and D. I'm going to hit pause. You're going to check your work or do your work, then come back and check it. Once again, we got a little tricky on you there. Number C. Letter C is -9. The term is -9. There's no variable or combination of variables. Therefore, there's no coefficient. Does not exist. The constant is just that value, just that number. It's -9. For D, we actually have 2 coefficients. I have the same variable x, but one is squared and one is to the first power. So I have 2 coefficients. One is 1x squared, and negative 5x's. So my coefficients are 1 and -5. The constant, the value that doesn't have a variable in this case, is just, excuse me, is just 4. All right, with that said, we've kind of taken care of a few things. I got one more set of just kind of introductory work that we got to take care of here. So let's go ahead and go to the top of the second page. We need to write the following polynomials in standard form. In other words, go from the biggest exponent down to the smallest exponent, and then with no exponent or no variable, which that's the constant, right? So I'm going to do A, and I want you guys to try out B and C. I've got -2x plus x squared minus 3. Well, it's all x's, but the biggest exponent of those x's is squared. So I'm going to say x squared, then minus 2x minus 3. Our degree, the biggest exponent I have is 2, and the leading coefficient, what is the coefficient of x squared? I have 1 x squared, so my leading coefficient is 1. Okay, gonna hit pause in here. I'd like you guys to try B and C, then unpause, come back and check your answers. All right, for letter B, 8 minus 7x, we need to put the stuff with variables first. So it ends up being negative 7x plus 8. Our degree, or the exponent of x, if you don't see an exponent there, it's just assumed to be 1. It's just 1, right? And then our leading coefficient, what's the coefficient of the leftmost variable, or the leftmost term, I'm sorry, the leftmost term, and that's negative 7, because I've got negative 7 x's. In letter C, we've got something, an x to the 4th, to the 3rd, to the 2nd, and to the 1st power, so I rearrange that in standard form. Negative 9x to the 4th, negative 9x to the 4th minus x cubed plus 6x squared plus x. So I've taken care of putting those in descending order. The largest degree that I have is to the 4th power. That's my biggest exponent. And my leading coefficient, what's my coefficient of the leading term, is negative 9. I have negative 9x to the 4th. All right. So that's just kind of some stuff to get out of the way, to remember, not to get out of the way, but to bring you back to what those mathematical terms mean and how we use them. And also to kind of preview, bridge what we're going to do a little bit later in class. So what we're going to do, though, the first part of what we're going to do, we're going to add and subtract polynomials. Now, adding and subtracting in polynomials is something that you've done a lot. It's something that you have experience with. And the biggest thing that holds you back, or the biggest struggle, is not taking your time. I'm guilty of it sometimes too when I try to rush through things. So we're going to go ahead and do this in a logical fashion. What I'm going to do is I'm going to do 2 addition problems. I'm going to do A and C. Then you're going to do B and D and check your work. Then I'm going to come down here and do subtraction problems and show you how they're the same thing. I'll do E and G. Then you're going to do F and H and check your work. And then we'll go back on, then we'll go on to multiplication. So let's go ahead and get started here. To add and subtract polynomials, combine like terms. Don't add exponents, and write your final answer in standard form. In other words, largest exponent to the smallest exponent. Now I'm looking here to see, I've got 2 sets of parentheses, but what I don't see is anything to distribute through. In other words, both these sets of parentheses are essentially being multiplied by 1, just multiplied by 1. So if I distribute 1 through the first set, I have 4x squared minus x cubed plus 2 plus 5x to the 4th. And if I distribute through the second set of parentheses, I have negative x plus 6x squared plus 3x to the 4th. What I'm going to do here is I'm going to try to identify where is my biggest exponent. My biggest exponent is to the 4th power. I've got 2 terms like that. I've got positive 5x to the 4th and positive 3x to the 4th. That gives me 8x to the 4th. Now I need to look, do I have any terms with x to the 3rd power, x cubed? I don't have anything over here, but I do have one right here, minus x cubed. Notice how I'm not crossing anything out here. That's one thing you guys like to do sometimes. Don't cross them out, because let's say you made a mistake and you wrote in pen and now you got to go back and look, but you're just like, I don't know. Don't cross things out. Okay. Underline them, put a check marks, and do something else like that. I'm looking for squared terms now. I've got 6x squared and 4x squared. They're both positive. This becomes plus 10x squared. I have one term with x, it's minus x, and one constant, plus 2. Right there we go. 8x to the 4th minus x cubed plus 10x squared minus x plus 2. I'm not saying that this is easy, but what I'm saying is if you take your time and use your mathematical skills, you can get to the right answer, but take your time. Now, I'm going to do C here, and holy cow, look at all these things going on in here. I'm going to distribute, again, positive 1s through because there's nothing other than just a 1 to distribute. We have 17x to the 4th plus 8x squared minus 9x to the 7th. Oh, interesting. I'm going to keep that one in mind, see if there's anything bigger than that. Plus 4 minus 2x cubed, distribute a 1 through, plus 11x cubed minus 8x squared plus 12. Whew, that's a lot going on there. I did see, if I go back just a second ago, I did see this negative 9x to the 7th. That was the biggest exponent that I saw on x. And also, I only saw one of those. Since that's the case, that is our largest exponent. That's going to be our leading term. Now I look for 7, so I start with 7. So now I look for 6. Anything to the 6th power? Nope. Anything to the 5th power? Nope. Anything to the 4th power? Yep. Just one term though. Plus 17, x to the 4th. Anything cubed to the 3rd power? I've got 2 terms. I've got negative 2 and positive 11. That gives me positive 9 x cubed. In terms of things that are squared, positive 8x squared, negative 8x squared. Well, that's kind of nice. That's just 0. You don't have to write the 0 in, so we won't. Then we've got this 1, or sorry, we've got plus 4 and plus 12. So plus 16. Our solution for this one, again, these are expressions. We're not solving for anything right now. We're just trying to simplify, combine like terms. What we ended up with there is negative 9x to the 7th plus 17x to the 4th plus 9x cubed plus 16. If you want to take and organize these in kind of an above one another fashion, that's what I'll do here. I'm not going to explain that, but you can see what I do in just a second, because what you're going to do now is you're going to try letters B and D after I pause this. And when you're done, then you're going to come back and check your work. All right. Okay, I'm not sure exactly what happened there, but as you look through those, all your distributions there, you should end up with negative 4x to the 5th plus 8x cubed minus 6x squared plus 9 for G, I'm sorry, for F. And then for H, you should end up with negative 6x to the 5th plus 7x cubed plus 11x squared plus 13x. I'll even make that a little bit clearer here, plus 13x. All right, that is adding and subtracting polynomials. Again, that's something that you've done before. We just need to formalize how some of this stuff works. Multiplying polynomials, we have set you up well to do this. If you go to the next page here, multiplying polynomials, we have set you up to do this. You can either use distribution, which we've talked about, or the box method, which we've talked about. Just kind of what we did here. I'm going to do 3 of these. I'm actually going to do D, E, and F, and you're going to do A, B, and C. I'm going to show you distribution. I'm also going to look at one. Once we do the distribution, we've got all these terms to combine. We just put those in standard form after you combine the terms. It just becomes addition and subtraction. So what we're going to do, we're going to take care of that. And when we're done with that, we're also going to look at a polynomial identity. We're going to look at something kind of fun. Well, for me anyway, what I like. So I'm going to show you how I like to do these a couple different ways. I'm going to do distribution in a little bit different way than I've done in the past. What I'm going to do, I'm going to start with D, and I'm going to organize both polynomials in standard form before I multiply. I'm going to have x minus 6. This is negative 4x squared minus 8x plus 3. I've changed absolutely nothing. I've just rearranged the terms. I could do that. They're now in standard form. I'm going to distribute, but because I've got a lot to work with in distribution, I'm going to change the way this looks. I'm going to say x times negative 4x squared minus 8x plus 3, and then negative 6 times negative 4x squared minus 8x plus 3. Now this is still distribution. This is exactly what you normally see. Sometimes though, this negative 6 times all that stuff would be to the right of that one. It's the same thing, but I'll show you why I like this sometimes. So I'm going to do my distribution in here. It's not a t-chart, not a t-chart. If I do x times negative 4x squared, I've got negative 4x cubed. And if I continue to distribute, I have minus 8x squared plus 3x. On the bottom, I have 24x squared plus 48x minus 18. Those are my 6 terms that I have to combining my like terms. And if I do that, I have 1 cubed term minus 4x cubed. I have 2 squared terms, so plus 16x squared. I have 2 terms with x's, plus 51x, and 1 constant. I end up with negative 4x cubed plus 16x squared plus 51x minus 18. You'll notice kind of they worked on the diagonals. That won't always be perfect, but sometimes it does work out like that. So it's not a bad idea to rearrange them to look like that. Okay. I'm going to do F before I do E. E has 2 different variables, so I want to show you kind of the standard form how you do 2 different variables. We'll do our best for this. So for F, I've got 4x squared plus 3x plus 2 times 3x squared plus 2x minus 1. We're going to do distribution the same way. I'm going to take that 4x squared and multiply it by everything in the second polynomial times 3x squared plus 2x minus 1. These are already in standard form. That's nice. Positive 3x times all the stuff in there minus 1, and then plus 2 times 3x squared plus 2x minus 1. Now, going to multiply my distribution through 4x squared times 3x squared, that is 12x to the 4th, plus 8x cubed minus 4x squared. Go to my second one, I end up with 9x cubed plus 6x squared minus 3x. Hopefully you're seeing this diagonals business. 6x squared plus 4x minus 2. I've got 9 terms to combine. Fortunately, there's only 1x to the 4th, so 12x to the 4th plus 17x cubed plus, so that's 12 minus 4 plus 8x squared plus x minus 2. It kind of worked on the diagonals. Hopefully you can see those diagonals coming through there a little bit. Combine like terms. Again, we've done multiplication, we've done addition and subtraction. We're just formalizing it with you guys. Okay. What happens when you've got 2 variables? This is a really nice example of having 2 variables. I'm going to do x and then y. I'm going to take x in descending order, then y in ascending order. I'm going to show you what this looks like too. So 2x times 3x squared minus 4xy plus 2y squared. And also 5y times 3x squared. 3x squared minus 4xy plus 2y squared. And when I do that, make sure I get in between problems here. If I multiply 2x times 3x squared, that is 6x cubed. Then 2x times negative 4xy is negative 8x squared y. Notice how I'm keeping the x's first. Then 2x times 2y is 4xy squareds. Then I've got 15x squared y's minus 20xy squareds plus 10y cubed. That's just my distribution through there. Combine like terms. I'm going to go descending in x. So 6x cubed. Do I have an x squared? I do. Minus 8x squared y plus 4xy squared. Oh, hold on. I got a little ahead of myself, didn't I? 6x cubed. These two are the same. They have the same. So positive 15x squared y minus 8x squared y. So plus 7x squared y. I've got negative 20xy squared and positive 4, so minus 16xy squared, and then plus 10y cubed. You'll notice that the x terms go down in descending order, so cubed, squared, and then the first power. And my y's go, I have no y's, y to the first, y squared, y cubed. If you can do the best to rearrange it that way, I'm not going to be too picky about standard form for multiple variables, but this is a way to keep your stuff organized. With that said, what I need you guys to do now, hit pause. You're going to do A, B, and C. Then come back and check your answers. All right, as I bring you back, we check A, B, and C. A, B, and C. A ends up being 2x cubed. minus 7x plus 2. That's because your negative 4x squared and positive 4x squares simplify to 0. B ends up being negative 21x cubed plus 31x squared plus 2x minus 8. And letter C ends up being 10x cubed plus x squared minus 13x plus 12. All right, so a lot of distribution going on there and a lot of simplifying terms. It's a lot of just minding your P's and Q's, making sure things are in order, understanding where things go, how the descending order stuff works, all that kind of stuff. It's just about being meticulous, okay? Dotting your I's, crossing your T's. Speaking of meticulous, let's look at this bottom one. This one's got 3 variables. Mr. Brayman, what are you trying to do here? Verify the given polynomial identity. In other words, what I want you to do is I want you to make x plus y plus z squared into all this: x squared plus y squared plus z squared plus 2xy plus 2xz plus 2yz. How are we going to do that? Well, let's use our definition of what things being squared means. X plus y plus z squared is x plus y plus z times x plus y plus z. And let's multiply this polynomial x times x plus y plus z, and then plus y times x plus y plus z, and then z times x plus y plus z. And what do? X times x, we get x squared plus xy plus xz. Notice how we're keeping the first letter first, or the like x then y then z. And our second one, we have xy, because y times x is x times y, plus y squared plus yz. And our third one, we have xz plus yz plus z squared for our distribution. Let's see if we can make this match. Do we have x squared, y squared, and z squared? We do. X squared, y squared, z squared. So x squared plus y squared plus z squared. Do we have 2xy's? I've got one here and one here. Okay, so plus 2xy. Do I have 2xz's? One here, plus 2xz. And do I have 2yz's? I have one here and one here, plus 2yz. We just used our multiplication and adding and subtracting skills to verify that those two polynomial identities equal one another. All right, with that said, you have what you need and the necessary tools to take care of Poly2. If you have questions, please ask them in class, send us emails, look up another video if you want to, do what you got to do. Hope you guys have a great day. Take care. Talk with you later.